Question 10 says, what is the strongest intermolecular force in CHF3? So the first thing we need to do is to draw the Lewis structure. Before we do that, I want to write the intermolecular forces out so we have them for future questions. So the first intermolecular force that we have, and the weakest, is dispersion, which is present in all molecules. This is induced dipoles by collisions. So molecules bounce into each other. The electron clouds get temporarily messed up, which causes temporary positive and negative charges and causes the molecules to stick together. Remember that intermolecular forces is the forces holding two water molecules together, not the forces holding the H and the O. That's a covalent bond. But the force holding, not just two, but multiple water molecules together. Okay, dispersion is present in all molecules, and larger molecules, in this course as measured by molar mass, equals larger dispersion forces. All right. The next type of intermolecular force, which is stronger than the dispersion force, is dipole forces. And this is for polar molecules. And we don't talk about it a lot in this course, but molecules can be more or less polar. Okay, but polar molecules have these dipole forces. And then finally, we have H bonding. And in order to have H bonding, we need one of three conditions to be present. We need to have an N directly attached to an H, an O directly attached to an H, or HF, an F directly attached to an H, but the only example is hydrofluoric acid. Oh, you can't see that. So we need an NH, an OH, or HF. And the strength of these intermolecular forces increases as we go down in this order. So dispersion are the weakest. It's missing an R. Dispersion are the weakest, dipole, and followed by hydrogen bonding. So this is basically the order that we go in. So now let's take a look at this. So it says, what is the strongest intermolecular force in CHF3? Well, the first thing we need to do is we need to draw CHF3, the Lewis structure. So CHF3 looks like this. Now we need to determine what is the strongest intermolecular force. I like to start at the bottom with, sorry, this isn't all fitting on the screen here. Let me move it a little bit. I like to start at the bottom with hydrogen bonding and then work my way up. In order to have hydrogen bonding, we must have an H directly attached to an N, an AO, or an F. Well, this molecule has both H and F, but they're not directly attached to each other. So this molecule does not have hydrogen bonding. The next one is dipole, because it asks for the strongest type of intermolecular force. We know it doesn't have hydrogen bonding. Does it have dipole? In order to answer that, we need to figure out if the molecule is polar. In order for a molecule to be polar, all four domains can't be the same. So if you look here, we have one H and three Fs. Not all four domains are the same. So this molecule is polar, and its strongest intermolecular force is dipole. So to see if a molecule has dipole, you need to draw the Lewis structure and see if it's polar. Again, it's polar if not all four domains are the same. So if they're not all the same, it's polar. So in this case, the answer is dipole. This molecule, of course, has dispersion forces as well, because all molecules have dispersion forces, but that's not the strongest intermolecular force because dipole is stronger.